Okay, so as was pointed out, this is about the upcoming UPSERT feature coming in the soon-to-be-released PostgreSQL 9.5. For me, this is a very large project lasting several years. I started thinking about this problem in about 2012. Early prototypes appeared in about 2013, and it was a long road that I walked, and I think we ended up with something that was better for it, and I'll go into in the talk why I think this is so, how I feel it handles a lot of edge cases very well, and in short, addresses the problem, in my view, better than any other system out there today. Okay, so first of all, what is UPSERT? It's kind of, well, the term UPSERT itself is informal, although it does appear in the PostgreSQL documentation. It's generally understood to mean this idea that you insert a row or update an existing one on the basis of it there being what you might consider to be a duplicate. Typically, this is a row that has the same primary key value. Now, it may be that other systems don't exactly adhere to this definition, or that it's not entirely clear that they do, because I feel that it's very important that certain particular properties are maintained. So what I mean here is that it's important to me that we allow users of the feature to more or less worry as little as possible about concurrency considerations. In short, we worry about concurrency, so you don't have to. I'm equivocating a little bit here by saying more or less, but it is essentially the case that you will not have to give too much consideration to that above and beyond what you may, for example, have to give it consideration you might have to give for an ordinary update. Okay, so I use this term fundamental UPSERT property. It's some jargon I invented to try and formalize this idea. Hopefully that is in fact what the term UPSERT will eventually be understood strictly to mean, if it isn't already. I will say that MySQL's insert on duplicate key update does qualify here. I think it has some other issues, but to be fair, it does meet my definition. It does have these various properties. Merge, however, does not. That is the SQL standards merge statement, which you may be familiar with from other systems like SQL Server or Oracle. You write the UPSERT statement and you forget about it. That's what I want here. The lowest possible intellectual burden in using the feature. Okay, here I'm going to introduce the syntax. This is a basic example, or several basic examples. The first one being a simple UPSERT of 2 rows. The first is with value 5, the second with value 6. So these 2 rows are proposed for insertion, as I would say. So as you can see, I've extended the insert statement syntax. I've added this clause. So this high-level concept of an UPSERT is supported by way of this new clause. So on conflict, doUpdate will, in this instance, assign to dname the would-be inserted value in the event of a would-be duplicate violation. I think that's pretty straightforward and easily understood. I imagine so anyway. So this is, as I say, done on the basis of a would-be duplicate violation in respect of each row. So potentially one could be inserted, the other updated. They could both be inserted, they could both be updated. There is the second example appearing here is the insert ignore variant, which will simply ignore a row proposed for insertion in the event of a would-be duplicate violation. which is to say, it can be used. It'll do that without locking the row even, which the do update variant will always do. And the third example, slightly more complicated, shows how an additional criteria can be supplied, and it's necessary in order for the row to be updated for that additional criteria to pass. That qualification must hold. So here we're referencing the existing value within the special predicate, the zip code value there, and obviously if the existing zip code did not match, or if the predicate didn't pass, then it wouldn't be updated, despite the fact that there was a would-be dupe violation. Okay, and it would lock the row only if that were to occur. Wouldn't update, it would just lock the row. Okay. Here I'm highlighting the excluded pseudo table, which serves to allow us to reference those rows proposed for insertion. So the update part, if you will, sort of has a join-like feeling to it. It is sort of like update table from other table. So in general, updates will support a join. So you can basically update one table from values in another table in respect of multiple rows. So it sort of feels like update table from excluded, except, of course, the from excluded part is implicit here. That's what that means. Incidentally, this excluded alias carries the effects of before insert triggers. These, after all, may have contributed to the alternative path being taken if they were to modify values that were ultimately attempted for insertion. Okay. Now I'm going to highlight what I call or what we all call at this point, the inference specification, which you see here is the, in this case, DID column. So this is used to determine which of any unique indexes defined on the table or unique constraints ought to be used to arbitrate taking this alternative update path. This serves to make the DML author's intent clear. It's explicit what they mean to take that alternative path on. This is very important, I feel. It will allow us to determine one or more arbiter indexes, typically just one, which, as I say, serve this purpose. And we make you do this for UPSERT. We require that you specify your intent, because were you not to, it could be dangerous. You could effectively get logical corruption, which we hope to avoid, of course. I should point out that in the more or less equivalent MySQL feature, this is not available. So this is a sort of way of expressing intent and making it clear what it is you mean. If you neglect to, as I said, if you neglect to supply this, it will be rejected for the UPSERT variant, but not the do nothing or ignore variant. And if there's no unique index or unique constraint available that satisfies this inference specification, then you simply will get an error because it's not possible to execute the statement, essentially. Okay? So we want to keep the index that is driving all of this in any given scenario an implementation detail, because after all, indexes always ought to be an implementation detail. So we don't encourage people to name a constraint directly, although in fact that is supported. We prefer if you use this particular unique inference construct with the parentheses you see here. It's a very flexible and forgiving thing. So it doesn't care so much about ordering of indexed attributes, indexed columns, or expressions. It is something that will tend to just do the right thing in the event of real-world random stuff happening. I'll go into some of that a little later. Now, the question of, which is occasionally asked of me, why this? This is, after all, a non-standard construct. This is my thing that I invented. Now, in my defense, there are a bunch of other things that are also non-standard in other systems. I mentioned MySQL. There are others too. Merge is, some would consider to be the SQL standard take on this. However, I don't consider that to be so, because it, as I mentioned earlier, does not lack it does lack the fundamental UPSERT property. And so it does not provide any of these useful guarantees. It doesn't allow you to do things in a way that allows you to just write a statement and then give little or no further consideration to concurrency. It can, in practice, deadlock. They can deadlock with each other. You can get spurious dupe violations, imagining that the entire point of writing the merge that way was to avoid such dupe violations. So I thought people wouldn't be very happy with that. That old sort of cliche of giving people what they want as opposed to what they ask for perhaps applies here. So that was sort of the thought behind avoiding implementing merge. And furthermore, the fact that merge has all of these various issues is, in my estimation anyway, basically a laws of physics type issue. The syntax that it supports a very flexible join with arbitrary qualifications on the join, is not compatible with my goals that I've already mentioned of having it be simple and what some people call atomic. So merge cannot, and in practice does not, do any of this. So it's an unfortunate myth. The perception exists that it is not so, but this is no more than a myth. This slide here illustrates, this is from the PostgreSQL documentation. Perhaps some of you are familiar with this. It shows historically or traditionally how you would go about manually doing an UPSERT. This UPSERT does, in fact, have all these properties. It has some notable disadvantages, certainly. It is error-prone. It may spuriously raise, if in the event of, for example, a trigger raising a dupe violation, it might misinterpret that as the dupe violation that ought to have the update path be taken. So this involves a sub-transaction, and it involves attempting, I can't see it from here, I think it's an insert and then an update, and it must loop until one of the two outcomes occurs. In principle, they might not occur, neither may occur on the first try or even the second try due to concurrent activity, such as concurrent insertions or deletions. So this is the sort of old school way of doing it. Still works, and maybe some of you have done this. I know I have in the past. So this is what I'm replacing. Now, the problem with doing this, I mentioned the usability issues. It's also something that could consume potentially one sub-transaction per row to be upserted, or even worse, theoretically. And in general, PostgreSQL, you don't want to burn through sub-transactions or transaction IDs too quickly. That has various costs associated with it. So that's in general a bad thing. And it's also very slow. My implementation, or our implementation rather, performs a lot better. And it's just really ugly because, mean, it doesn't have to be a stored procedure. In this example, it is. But having to do one of these in each and every instance of requiring an UPSERT is, of course, a messy business. And people are just inclined to get it wrong in practice. So, do you remember how I talked about how merge doesn't guarantee any of these important properties? I mean, I'm sure you do. I just spoke about it. What's interesting is when I was doing some research on this, I realized that people had all kinds of complaints about merge along this line, along these sorts of lines. And I was looking at one thread on Stack Overflow, actually, about how someone proposed to solve their problem with merge with it not offering these properties. There was a lot of complaints about it. And the solution that a lot of people seem to be most fond of was this one, which is the exact same thing that we were doing to do UPSERTs, except it's a merge statement, not an insert or an update. And in fact, merge is, I can't really truly fault the other vendors here, because merge is, after all, in their words, a thing that is like a way of combining inserts and updates into one statement. It is useful for things like data warehousing, where having everything be a join, a conventional join, could be very valuable. For example, maybe it's internally a merge join, which could be a lot cheaper than having to go through a unique index for every row. But in general, I feel it's much less useful. So this and other examples I found on the internet clearly illustrate that there's sort of issues with merge. It just doesn't do what some people imagine it to do. So in short, UPSERT is about guaranteeing an outcome, whereas merge sort of operates in the standard way that queries will tend to operate. It doesn't do anything special with MVC or anything of that nature. So you can sort of simulate merge even with a with statement. It's kind of ugly. Don't recommend it, but it can be done. And as I mentioned, it's good for bulk loading and that sort of stuff. And in fact, merge doesn't even require any indexes be defined on the table, which is hardly surprising, because if it's for data warehousing, when you're doing bulk loading, often you won't have any indexes on the table deliberately, because it's much less expensive to create them afterwards. Okay. This is a bug that someone told me about in MongoDB recently. And I'm not in the business of mocking MongoDB, because it's not really my style. But I thought it was an interesting example of where this can go wrong. They had a regression in their wired tiger storage engine, where they had introduced more granular locking. And I imagine as a consequence of that, it now can have spurious duplicate violations. And I think historically MySQL had similar issues. So it's a very tricky business to get all of this right, and that's why I so strongly emphasized that as a goal of this project originally and now here. So, summary of UPSERT. We do the worrying about concurrency so you don't have to. Feel that we came up with a good syntax, balances various different concerns. There will be a little bit more about that in a while. So it's complicated internally in terms of its implementation, but it's designed to be as simple as possible to use, really all about reducing that intellectual burden of getting things right all the time. One other difference with merge is that inserting is an outcome that you have to be happy with, a possible outcome that you have to be happy with all the time. Merge doesn't require that you even have an insert handler in the statement. So in that sense, I suppose merge is also more flexible, but not in other senses. OK. So talking now about new use cases, some slightly less obvious things you might want to do with the new facility. So this is kind of the main section of the talk, if you will. At this point, I will take questions about UPSERT in isolation before I move on. If anyone cares to ask any questions about UPSERT in general, I might take those now. Yes?
Well, just that the one thing you said is that you're guaranteed not to have any conflicts if you're in isolation.
Yes.
So what are the issues with serialization? What might you run into? Just the normal stuff, or are there special considerations?
There are special considerations, but they don't really affect you as an end user. Basically, because in principle, your MVCC snapshot might not see any row version, you might have to look into the future, if you will, to find a row version that has the key you're looking for in order to support all these guarantees. So basically, with serializable isolation level, if the thing you had to look at is not visible to your original snapshot, you'll get a conventional serialization error. But really, it's not. That's a fairly obscure issue, not worth pointing out in the documentation or anything. It's just really no major considerations.
It's the same sort of stuff you get with serialization anyway.
Right.
Oh, okay.
Right. Maybe the novel thing about UPSERT, I'm not talking in particular about isolation level here, but in general, in terms of MVCC rules, is that it can affect a row where no row version is visible to the MVCC snapshot of the statement. That is a new and novel thing. So, but that doesn't particularly concern higher isolation levels. Anyone else? Yeah. Okay. Oh, yes.
So why not have on-conflict default to your primary key?
Probably no good reason not to. I mean, I just didn't get around to it, I suppose. I guess that, it's totally possible. Yeah, I mean, I wouldn't have a problem with that. Sure. Yes?
If you have, if your unique index constraint is across multiple columns, you would need to list all the columns.
Right, that's correct, yes.
As opposed to
Yes.
listing the
Right.
index itself.
Yes. Now, you could potentially list if there was an underlying constraint, which there isn't necessarily with a unique index, but often is, you can name the constraint using an alternative construct that I haven't shown you yet. Yes, you would have to list all the columns, and you can have a unique expression index in Postgres. You might have to list the expressions if that was what you were targeting. But it's actually very flexible about the ordering of stuff. You can put them in the wrong order, and it's fine. You can repeat them, and it's fine. They can be repeated in the index, and it's fine. So a lot of different things are handled. I'm pretty sure we've almost completely eliminated any way that you could inadvertently have an issue. Anyway, moving on. So I'm going to talk about data integration now. At a high level and how I feel UPSERT relates to that. So data integration is generally about integrating a bunch of data from different places where uniform access is required, where there's diverse sources. These may be autonomous and distributed, and essentially more or less outside of our control. There's different ways in which more or less equivalent concepts are represented, perhaps in each of these different systems. Could be other databases, could be other business information type systems, and we must fit everything into a mediated schema. So we have this uniform SQL access. A really crude example of this is, screen scraping, which is, I guess maybe some people here use the service Mint, which the way it will pull in your bank information by basically a Rube Goldberg device that pretends to be a person reading your bank web page because they're, if not downright hostile, they're not too keen on you doing that, or they don't care. So that's maybe a really extreme example of the kind of thing I'm talking about at a high level. So you can also have differences in terms of units. Maybe if you have products coming from, say, Canada, maybe they're using metric units, that sort of thing. And these things are perhaps ill-specified or sloppy because that is the commercial reality of the domain you happen to be operating in. You can't very well just decree that they should, have a consistent standard because they don't want to. It's a common enough sort of issue, and that's sort of what I'm going to be talking about here. So I also think that it's important idempotence, which is this idea of UPSERT statements being executed multiple times without changing the result beyond the initial application. It's an important property, and it is something that it's possible to get with this new feature. A more cutting-edge modern example might be the Apache Kafka system. Makes no strict guarantees about multiple deliveries of messages. So if you were using that to put data in Postgres, you might have to account for that by, it might not do to just have a dupe violation every time that happens for obvious reasons. With a lot of concurrency especially, the need to reconcile everything, to have only one authoritative version of everything is sort of in tension with MVCC to some extent, or at least was before. And when you're doing ETL, which has always been a problem, doing some kind of fencing operation to account for that, making sure that other people aren't writing to the table or something like that, so there's not concurrent conflicts of some nature, is really just not very convenient. So. So my perspective in general here is always a good idea to get a nice, simple, clean abstraction that works well and sort of leverage it to the hilt. And I think that's the case here. I've got a simple, clean abstraction, and I think I can sort of rely on that to sort of do the right thing. Especially the case that because I'm making the correct thing also the easy thing, things will tend to just work. And I think that's a very important thing to aim for. Okay, here's my example of an accidental distributed system. It doesn't involve Kafka. It's a simple example because that's easy to understand, but also because I think it illustrates my point about making the correct thing also the easy thing, and having that all work out without necessarily having people be expert on these issues. Okay, so this is what I'm talking about here at high level, a retail system that syncs with disparate suppliers. It does this using an ad hoc text format. Each of these suppliers may sell the same product, so they're not necessarily the end manufacturer. They are, that is upstream in the supply chain. They're simply syncing in using all of these various ad hoc, ill-specified formats. These are autonomous. These wholesaler or supplier business information systems, you're downloading an ad hoc format over something very crude, perhaps even as crude as something like FTP. And there's no sort of business pressure for everyone to standardize, and so it is. And there's a lot of legacy concerns. This is kind of a boring example maybe, but one that I had to deal with in a previous life, so I'm drawing upon it. Okay, here's some example tables. We have a product table here. This table concerns an authoritative record of products that are sold on to end consumers. So this is self-explanatory. Maybe these suppliers imagine that they're the sole supplier of every product that is sold on to end consumers. But of course, this isn't so. So they're not really respecting the kinds of distinctions that our business information system, the one under our control, ought to. So this is very kind of an old school business. It is necessary to update everything a certain way where you have essentially a list of products and their details and they need to be updated from disparate suppliers and reconciled, and we have to consider the validity of every supplier's description and so on of the product. So this example shows inserting a new product from, say, a comma-separated values file or something terrible like that. This shows a timestamp with a, indicating when the new details were effective from. Now this also shows the predicate, and this allows us to not affect any version of the table, or rather any version of the, if the supplier's own timestamp representing when the record is authoritative from is newer than, or rather older than what we already have, then we maybe don't want to apply it at all. We especially don't want to do that if it's affecting the general concept of the product record, like its description, say. So by having this predicate, we're avoiding all of that. To re-emphasize this sort of simple enough example, so maybe if you were doing this the other way before, it wouldn't really matter because it tended to be that you wouldn't get race conditions because it just there wasn't enough interleaving of things. But, that's really not good enough because there will be one day and you won't know about it. Because how can you test something like that? It's impossible. And so, in a way, the reason I didn't do a more kind of, I didn't use something like Apache messages or something like that, Apache Cassandra, or rather Kafka messages, is because, you have to think about it there. But it's kind of, I'm trying to make the point that even when you're not thinking about it, you're still getting the benefit of it, and you're going to do it that way because it's the simple way, and you get these sort of network effects of everything being simple and correct just because that is naturally the way you do it. And that's the big picture. Bruce?
And your point is you can have 100 people doing this all simultaneously.
Right.
It's all going to work.
Exactly. And you probably don't even consider that could happen, and it probably won't happen until it does. And that's kind of what I'm, really want to emphasize with all this work. That's the point of me using such a, like a fairly rudimentary business information system example, because that's where these problems happen, because they don't test, because they don't know. So that's what I'm trying to get across. Okay.
Or you, for example, you buy a company.
Or you buy a company.
You
Yeah.
have control at all over their format or whatever. You can't change.
Yes.
You can't just go make them changes.
Right. And even if you can sort of apply pressure for them to standardize or something, everyone else is applying pressure for them not to because they've bought into the old way of doing things, and there's all kinds of legacy concerns and so on and so forth. And in short, the world is a messy place when it comes to this kind of thing. And it's, it's kind of a ivory tower thing to say, well, we should just simply, decree that everyone's going to do it this way. Well, it ain't so the real world, and I'm quick to acknowledge that. Okay, so I'm going to talk a bit more about more advanced capabilities that I touched on initially. So I'm sort of back to just talking about UPSERT again now in the abstract. Okay. We've seen already how it can selectively update a row. We'll see a bit more of that kind of thing. And, again, talking about intellectual burden of doing all this stuff, everything has to work together seamlessly. Other features must, too. A great amount of the difficulty in working on this was getting all that detail work right with other features. Whatever your existing favorite feature is, it probably will work very well with this thing. Okay, another example. This is, in fact, sort of referencing the practical example I gave. suppose you have, in the same, for the sake of argument, the same business information system, a concept of a logical deletion. You must retain product records because, for example, you might need to see historic sales for products that are no longer sold from, we'll say, 5 years ago. So you must retain those records at some level, on the one hand. But on the other hand, you have to consider that you will, have to delete things. But then maybe they'll have to be reintroduced. So what if you have, how can you have something reintroduced and have a new version of what is essentially the same product? You can have this, there is a way of doing it and having constraints that respect everything. Having a unique constraint that will make sure that in respect of products that are currently active, that have not been logically deleted, that they will, for example, have unique UPC barcodes. But if you happen to delete them and re-enter them, then there actually ought to be an SKU or something like that. That is the sort of the thing that really, like maybe even just a serial column or something like that, which is not included here. So you have this. If you have this Boolean is active column, you can represent this idea, and then you can create partial unique indexes that will make sure that as I say, that those constraints are respected. So what of UPSERT? Sure, UPSERT will of course roll with this very well, because you didn't see before. Now you saw that there was a where clause at the bottom after the update, but this is a different sort of where clause. So in fact, this where clause is part of the inference specification referencing the UPC barcode. So what we're saying here is, effectively, infer a unique index which may have maybe a partial unique index which is active, where is active, the Boolean column is true. So we are saying, that would be acceptable if that's all you got. So we're making everything work with that previous useful concept of a partial unique index right here. Pardon? Well, this where clause can be, it's essentially using the same grammar that we use for create index, so it is exactly complicated enough to infer any partial unique index. However, the other previous where clause, yes, the one that would be at the bottom, there isn't actually one there, but there could be. That one can be basically arbitrarily complicated. It is completely unrestricted as compared to any update. Or I think what the question you were asking was sort of, because you're probably aware, now that you're aware that merge does not allow you to do subqueries in the way you might expect. That restriction does not apply here. So, good question. Okay.
So I noticed on the very first create table.
Yes.
The unique index was barcode plus producer ID or something.
Oh, sorry, you're right. I forgot to enter the. You got me. I changed the slides at the last minute. Yeah.
No, that's fine. I was wondering if that was the where clause here was actually to add that other. I mean, what this where clause
Yes.
is actually doing is put it in on another index
Well,
as well as the original index.
If such an index exists, yes. So in fact, and this is sort of what I was about to mention, having this where is active thing here only means that it would be okay if that was the only one, one that was partial. But let's say you didn't have a partial index. You had an ordinary, unremarkable primary key. That would actually work with that as well. It's only necessary for you to satisfy, as I would say, the predicate, as opposed to matching it exactly. So again, it's another example of everything being very flexible and forgiving. That's sort of where I was going with that. Okay. This is all sort of about safety. So easy to use correctly and hard to use incorrectly. So sort of wanted to get that right, as you can pick up on, is a very important consideration of all this work. And I think this is, a significant competitive advantage for PostgreSQL as compared to any other system, that it has this level of thought, this detail work, as regards getting the right condition to take the update path on, being forgiving of migrations occurring where you have essentially two equivalent unique indexes at the same time, making sure that it just does the right thing with the minimum of fuss. Okay, this is an example of explaining an UPSERT statement. Now, maybe you're not all aware of the fact that you can explain any sort of DML statement and insert an update or a delete. This is, of course, no exception. There's a couple of novel things here you're seeing, though. You're seeing here this listing the conflict arbiter index. There's just one here. There's usually only one, of course, but occasionally there may be two. You're also seeing a conflict filter here, showing this essentially, and you'll be able to tell how many rows were inserted, how many rows were updated based on that. So here's an example, sort of, as I was saying to you just a moment ago, of having two indexes, one the primary key index, the other a partial index, because I've added the where is active here. So now you're getting two. Now, mostly this won't happen, because why would you have two like that are essentially or more or less equivalent? You probably wouldn't, except maybe there's a migration, that kind of thing. So I'm just showing that is all. It's all there. It's all there for you to make sure you're getting it right. Okay, a little on more advanced inference and how it can be more flexible. I mentioned already it supports expression indexes and is forgiving of ordering and redundancy and so on and so forth. And I also mentioned the predicate on the inference specification will work with any index that satisfies it, which may, in fact, not be a partial index. And I also mentioned earlier that there is a onConflict on constraint name variant that is not generally recommended. You ought to prefer the inference specification that names columns directly, because you're buying into this whole flexibility thing, which is very important. There is one exception, though. OnConflict do nothing supports exclusion constraints. Some of you will be aware that exclusion constraints are an existing PostgreSQL feature that's sometimes called a generalization of unique constraints. What does that mean? Well, it means it allows you to create what is sort of like a unique constraint, generalized not just for an equality operator, but for example, an overlaps operator. That might be useful in event planning, so we're occupying this room currently, and because we're occupying this room, obviously there could not also be another talk in this room. So one way of fixing this traditionally might be to have like time slots that are fixed, and so you could just use a unique constraint then. But what if you require more flexibility? You have discrete ranges of time. So you have like an overlap. You want a constraint violation when two uses of one particular room overlap, and that's really what exclusion constraint is all about. Now, UPSERT does support these. Well, actually, UPSERT doesn't, but the do nothing variant does. That is, you can do an insert on conflict, do nothing. You can ignore would-be exclusion constraint violations also. It doesn't work with UPSERT because that would not be meaningful or useful, but it does work with do nothing. So it's very flexible as well in that you can even support things like alternate collations if that was ever useful, which it probably won't be, and things of that nature. So extremely future-proof. I'll talk a little about other advanced features now. Postgres Foreign Data Wrapper is this extension that allows you to have a concept of a foreign server. In this case, it's a foreign PostgreSQL server, as is always the case, which you can have foreign tables within your local database that can more or less be queried as if they were on the local database, even though, of course, they are not. They may be accessed using a regular PostgreSQL connection internally, but there's a reasonably robust abstraction where it appears to be the case that they are local tables in your local database. Now, the do nothing variant does work with this, but do update does not. That's just because there's no concept of a foreign table with a unique index on it, or any kind of index for that matter currently. Maybe we'll address this in the future. I'm not so sure. Or else the row-level security feature upcoming in PostgreSQL 9.5 also works very well with the feature. A lot of work went into that. So you can trust that provided you have your security policies set correctly, UPSERT ought to more or less just work with that. And that's nice too. Datable views also work. So in general, the chances of you finding any point where UPSERT doesn't do what you want it to do because of some limitation in terms of its interaction with some other feature, probably not going to happen. I think we really have almost thought of everything. Logical decoding plugins, incidentally, will report inserts or updates by the UPSERT statement as inserts or updates. There's a new 9.5 feature. It's a nice little convenience. You can use a subselect within an update to have multiple columns be updated by multiple columns appearing in the subselect. That is, of course, also supported here. And this is the question Joe Selko asked a little earlier about any restrictions. I mentioned that, yes, I see. I mentioned that the restrictions on the feature were basically there really were no restrictions on the structure, unlike SQL merge, where you can't just put a subquery anywhere you like. You can put a subquery anywhere you might care to here, really, and it'll just work. And returning is supported, and returning will return any rows that were inserted or updated. So if your update where clause, the additional criteria that must pass in order for an update to affect the row, if that doesn't pass, if a row isn't updated, then it won't be protected by returning. So anything that's inserted or updated will be protected by returning. And you can put it in a with statement as well, and you can pipeline them. You can do everything. Well, yeah. It's that's sort of true. Although, of course, merge, would be useful if you had if you were a huge data warehouse where you were doing a bulk load. You didn't care about concurrency. But my observation is, even if you think you don't care about concurrency, maybe you do. You could be wrong one day. So just having it.
Would there be a way to differentiate those that were merged?
There's no documented way, but you can do it by looking at xmin, which, yeah, it is technically possible, but it's kind of a kludge. Yes. There probably ought to be a way of doing it that is not a terrible kludge, and maybe there will be soon. It's not very complicated to do. It just didn't get done. You can. You ought to be able to do that. I agree with you. There ought to be some kind of expression that will do just that. Okay, I'm almost out of time. I will take more questions on anything I've said since the last. Yes, sir.
So in addition to that, you get the list of things that were explicitly excluded, even though you had a conflict resolution for some of them.
I'm sorry.
So you can say on conflict with, the specific clause.
Yes.
With a where clause.
Mm-hmm.
So you're only going to handle those things that match that where clause. What about the other things? What are the
Well, it doesn't. It works one way, but not the other. In other words, if you have the where clause on the inference specification, what you're essentially saying is, I would be okay if the only unique index available was one that happened to satisfy this this clause, this partial clause of yours. But that doesn't restrict it to only such. If it matches in every other respect, then that will also be in the list of things you're using. It's a safety feature, essentially. Whereas if you didn't have it and you only had a partial unique index, which if it was a partial unique index, it probably would be the only one, and it matched it. But even though it matched in every other way, then you would get an error from the optimizer because it would essentially not be able to match your inference specification. So it works one way, but not the other way. I think is that it doesn't have to be an exact match for that part. Just sort of like you don't have to get the exact order correct, things like that. Anyone else have any further questions? No? Okay. I think I'm done. Oh, thank you.